This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. NASA is testing high-bandwidth laser or optical communications for the first time beyond the Moon, with a pioneering technology demonstration called the Deep Space Optical Communications, or DSOC. DSOC is attached to NASA's Psyche spacecraft, which launched in October of 2023, and will send and receive signals during the first 2 years of its 6-year journey to the metal-rich Psyche asteroid. Phase 1 of the test was successfully completed in July of 2024, when Psyche was about 240 million miles, or 390 million kilometers, from Earth, more than 2.5 times the distance between our planet and the Sun. The project achieved a sustained downlink data rate of 6.25 megabits per second with a maximum of 8.3 megabits per second. Though this rate is significantly lower than the experiment's maximum, it is far higher than what a radio frequency communication system using comparable power can achieve over that distance. The goal of DSOC is to demonstrate technology that can reliably transmit data at higher data speeds than other space communications technology like radio frequency systems. The project sent unique data sets of art and high-definition video along with engineering data from the Psyche spacecraft, transferring almost 11 terabits to and from the spacecraft. The flight transceiver is powered down now and will be powered back up on November 4th. That activity will prove that the flight hardware can operate for at least a year. From Jet Propulsion Laboratory, Bill Klipstein, the DSOC project manager, and Abby Biswas, the DSOC project technologist, explain how DSOC works and its advantages.
In our everyday lives on the ground, we use optical fibers for really high-speed communication, and that capability has been adapted for use in space near Earth. DSOC stands for Deep Space Optical Communications, which is using lasers to communicate at high rate, and the application of that to deep space beyond the Moon is what the DSOC project is about.
Primary objective is to give future NASA missions the tools for returning data at much higher rates.
The signals travel at the speed of light, so they come just as fast as they do for the microwaves, but you could send more data in the same time of a pass for the same spacecraft resources. The notion of being able to communicate, have video to astronauts on Mars is actually part of the vision that NASA has for optical communications. DSOC consists of a flight terminal that flies on the Psyche spacecraft, and then a ground network that has a station for transmitting up to the spacecraft and then receiving the laser signal down from the spacecraft.
Here we have to send a laser beam from Earth that the spacecraft has to receive, use as a pointing reference, and then initiate the communication link. So it's a very flight and ground joined at the hip kind of telecommunication system.
DSOC is being implemented as a technology demonstration to show that we know how to build terminals that can do this, with the idea that in the future they can be flown as part of the operational communication system on future missions. And we designed the terminal to operate out to about Mars' farthest distance. And Psyche on its cruise actually does a Mars flyby, so it's an excellent vehicle for the demonstration of deep space optical communication. DSOC is the first time that there'll be optical communication demonstrated beyond the Moon.
The leap that DSOC is taking is huge. I can't express in words, what this will mean to actually see bits that were transmitted from deep space spacecraft received on the ground, and we can verify that, hey, we got the bits that you sent, here they are. Before that moment of elation and joy, there's a lot of work that we still need to do and think through.
And so this is a stepping stone for a future operational capability that NASA's committed to. There's a lot of activity in space and a lot of collaborative work that goes on, and it's very exciting to be part of.
This kind of laser communications technology could help revolutionize deep space communications. Thank you for joining me, and thank you for listening from your home or where you work. And wherever you listen, be sure to like and follow us. Listen each Tuesday for This Week in Space with John Gomez. And join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.